Hi, and welcome to Dr. V's Chemistry Webcast. In this webcast, we're going to be discussing classes of chemical reactions. So what should you be learning in this webcast? Well, first, we're going to compare and contrast the 5 main types of chemical reactions that we study in a first-year high school chemistry course. These 5 types include synthesis reactions, decomposition reactions, single replacement, double displacement, and combustion reactions. And we're going to talk about the patterns that go along with each one to help you recognize them. Okay, so we're going to start by discussing synthesis reactions. Now, the word synthesis, as you may know, refers to putting things together, making things. So when we're talking about a synthesis reaction, we've got 2 or more reactants combining to make a single product. Most synthesis reactions have a single product. So we can think about it from a very simplified formula sense, A plus B making C, single product. We can look at it from a particle level diagram, a visual representation, and we can actually look at an actual example. 2 atoms of potassium can react with a molecule of chlorine gas to make potassium chloride. The next type of reaction that I'd like to discuss is decomposition. Now, decomposition refers to breaking things down, breaking them apart. So that's really what's happening in a decomposition reaction. It's a really nice description. We've got a single reactant and it's breaking down to form 2 or more simpler products. So we can think about it, AB is making A plus B, or we can look at it from a particle level model, a descriptive picture again. So we've got the one compound and it's making 2 simpler products. And we can look at it from an actual chemical equation. Baking soda, when it's heated, decomposes to make sodium carbonate and carbon dioxide gas and water. The next type of reaction that I'd like to discuss is generally referred to as single replacement. So what's happening in single replacement reactions is you have an element reacting with a compound. And when they're done reacting, you have a different element and a new compound. So A can react with the compound BC. A can kick B out of the compound. A and C end up together in a compound, and B's the element. We can look at it from a visual representation. We have the green atom reacting with the yellow and blue molecule. The green and blue atoms end up together, and the yellow atom takes off as an element. A real-life example of a single replacement reaction involves copper reacting with a solution of silver nitrate. The copper kicks the silver ions out of the silver nitrate, takes its place. We end up with copper 2 nitrate and silver atoms. The next type of reaction I want to discuss are referred to as double displacement reactions, or sometimes double replacement reactions. Either name is fine. You'll hear both of them. So what's happening in a double displacement reaction is you start with 2 ionic compounds, and they switch their cations, and as a result, 2 new ionic compounds are formed. So we could say that AB reacts with CD, and then the cations A and C switch partners. So we end up with A and D as a compound and CB as a compound. We can look at it from a visual model, a particle level model, and a real life example of a double displacement reaction would be silver nitrate in solution reacting with sodium chloride in solution, and what happens is the ions switch partners. So the silver ion and the sodium ion switch. We end up with silver chloride and sodium nitrate. And the silver chloride happens to be insoluble and it falls to the bottom of the beaker, and we call that a precipitate. The final type of reaction that I want to discuss are referred to as combustion reactions. And these are reactions that we rely on really heavily every day. We use them to heat our homes and run our automobiles. So what's happening in a combustion reaction is we have a fuel of some sort reacting with oxygen. And it's really the fact that oxygen is a reactant that makes it a combustion reaction. And the common pattern is that we make carbon dioxide and water. That's when we're focusing on the combustion of hydrocarbons, which is very typical in a first-year high school chemistry course. Hydrocarbons are compounds that are made only of carbon and hydrogen. And when we combust them, we get carbon dioxide and water. So what I really want you to remember about combustion, what makes it a combustion reaction, is oxygen as the reactant. And that's really what you're looking for. So we can write a generic formula for a hydrocarbon. We react it with oxygen to make CO2 and H2O. And here's a particle level model of a combustion reaction, CO2 and H2O. I do want to point out it's not always that simple because we can be reacting other things in our combustion reaction other than hydrocarbons. We can burn all kinds of things. Oxygen as the reactant, that's really the key here. I also want to mention that combustion reactions are very exothermic reactions. When the reaction proceeds, they release a lot of heat. That's why they're useful for heating our homes and running our automobiles, etc. We do combustion a lot. They're really important. Now, sometimes balancing combustion reactions of hydrocarbons can get a little tricky, and I wanted to show you one strategy you can use to make your life a little easier. Let's say we're looking at the combustion of octane, which is, of course, an important component of fuel. It's a hydrocarbon, so when we do the combustion, we're going to get CO2 and H2O. So let's start the balancing process, right? So I've got C8H18 as the reactant with oxygen. So that's 8 carbons, so I can balance my CO2s by putting a coefficient of 8 in front of it. And then I've got 18 hydrogens on the reactant side, so if I put 9 H2Os, that balances my hydrogens. But now if I go and count all my oxygens on the product side, that gives me 25 oxygen atoms, which is an odd number. And of course, the oxygen molecules on the reactant side are O2 molecules, which is an even number. So one way I could fix this is to use a fractional coefficient. I could write 25 halves. If I had half of all the atoms in 25 molecules of O2, that would be 25 atoms. Now there's a little problem with that, because in standard form, when we write a balanced equation, we don't write fractional coefficients. That's not cool at all at this point. That's not what we want. We want whole number ratios. We want the smallest whole number ratios. But what we could do is multiply the entire equation here by 2, and that will balance the equation. So that's just a strategy you can use if you want to help you balance your combustion reactions. So I'd like to wrap things up by summarizing the classes of reactions that we discussed. We started with synthesis reactions, putting together. 2 or more reactants come together to form a more complicated product. Many synthesis reactions have only one product. You can have synthesis reactions with more than one product, but one of them is definitely going to be much more complex than any other reactants. We also talked about decomposition reactions, falling apart. We have a single reactant making 2 or more products, and that's really the hallmark of decomposition, one reactant. We talked about combustion reactions. We focused on the combustion of hydrocarbons. Oxygen is the reactant. That's really what makes it a combustion reaction. We can combust all kinds of things. When we're doing combustion of a hydrocarbon, our products are going to be CO2 and H2O, and we're going to release a tremendous amount of heat. We had double displacement reactions or double replacement reactions. We have 2 ionic compounds making 2 ionic compounds. They switch cations. And we also talked about single replacement reactions. We have an element in a compound giving us an element in a compound. It's really helpful and important that you know these patterns and study them and do a lot of practice with them. If you found this webcast to be helpful, subscribe to my channel, leave a comment, like the video. Learn chemistry every day, study chemistry every day. That's the path to success.